Okay. Okay. Okay, recording. Okay, so today we will do KK coursework for your Maths T semester 1. Okay, so do you know what is the instruction for doing this? Okay, wait. Where's my camera? Okay, so do you know what is the instruction of doing this? Okay, you have your KK and then you need to write out your solution in a paper, not in a paper, in a set of paper. Okay. And KK, it can be very creative one. So meaning that your solution can be very creative. You can write something which is not in your syllabus into it, because this is what we call KK. Okay, it's some extension, some extra knowledge out of your syllabus a bit. Okay, and you can use also graphing calculator. Later I will show you. So please prepare your graphing calculator. So I will suggest you to use this one, Desmos. Okay, DESMOS. Have the app, have the online website also got. Okay. Okay. So this one just an introduction only, 2.4 assignment. Okay, so you can read through it. Okay, so deal with complex number. Every person will get the same paper. Every school, every student will get the same question. Okay, do it complex number. Yeah. Today we only discuss coursework. Okay. Okay. So you can read through it. Okay. Okay. So now for the task one. Okay, and also I give you the thing. Okay. Uh, for every semester you have different topic. Okay. For every year, every semester we have different topic, different chapter. So let's say in my year I get analytic geometry. In your year you get complex number, something like that. Okay, so we choose one chapter only. Okay, and I will tell you lah. Usually you got do means that your mark, you will have a certain mark, and your KK mark and your KK grade definitely is A1. Okay, so it is okay not to scare you write something wrong. Your teacher will help you also lah. Okay, but make sure give it quality. Okay. Okay, now we start task one. A complex number is a number defined x plus yi. So you all know lah. It's just introduction only lah. Okay. X is the real part. Y is the imaginary part. Okay. Now, this one actually I give you some hint already during my class. Okay. So, what is the I power to the n? N is any positive number. Okay. So here got so many number lah. Okay. So we do one by one. Okay. We do 1 until 8 first lah, the very simplest case. Okay, so if I power 1, anything power 1 is still the same. So this is still I. Okay, and then the second one, what is I square? You know I square because I is the square root of 1. So I square is square root of 1 and square. So you get back -1. This one you all should already know lah. I power 3, I cube. Okay, you can think of as a I 2 plus 1. 2 plus 1 and give it index rule I square multiply I. I square is -1 multiply I. So this is -I. The third one is -I. If you have done this one, the simplest one, then you just check only lah. Check your answer. Okay, I power 4. I2 plus 2. So I square multiplied by I square, -1 multiplied by -1, you get +1. Okay, what about 5? Okay, Albert Chiu, yes, we only discuss coursework. Okay, today we will discuss coursework. Okay, not other things. Okay, coursework only. Okay, I power 5. This 5 can be write as a 4 plus 1. Okay, 4 plus 1. Okay, if 4 plus 1, index rule, I power 4 multiply I power 1. Okay, what is I power 4? I power 4 is 1. 1 multiplied by I you get back I. Okay, you take out 4. For the rest of the case, also take out 4. So let's say I power 6, you make it 4 plus 2. Okay, I power 4, look at your previous result, 1. I power 2, -1. Okay, so actually, if I don't tell you, you can also see already the pattern. Okay, so this is actually 1 multiplied by -I, y, the third row and the fourth row. Okay, -I again. And the 8, 4 plus 4, I power 4 multiply I power 4, 1 multiply 1, get back 1. Okay, okay. Look at this pattern. Look at this pattern here. I, -1, -I, 1. And then come back again, become I. Okay, like how it is the first one, right? Get back again. And then again, -1, -I, and then 1. So what could you observe the pattern? If you can take out a 4, then it will just be the same as 1, 2, 3, 4, right? Okay. Now, I will give you a hint for 74. So if you have 74, I power 74. Okay, I ask you do one thing. What is 74 divided by 4? 74 divided by 4? 18, right? 18, 72, remainder 2. Okay? So 74 can be written as you have 80 multiplied 4 and you have a remainder of 2. Remember, this one division, so that you can write it in this form, you can check back, okay, why it is true. Okay, now, if we can write like this, then by index law, we can put it 18 multiplied 4 multiplied by I squared, right? Like this, okay, and then 18 multiplied 4, associative, change the order, I power 4 bracket 18, correct? Okay, check by your index rule. When multiply, it is bracket and then power another thing. Okay, multiply by I square, which is -1. Now, I power 4 is still 1. 1 to the power of 18 is still 1. So 1 multiplied by -1, -1. Finally, you get -1. Okay, so this is for the case 74. Okay, so it looks like you can generate a pattern already. Okay, so what is the pattern? Divisibility by 4. When you divide by 4, you look at the remainder. If remainder is 2, then it is the same number as this one, 2. Okay? So this is the case. So you can actually generate a pattern already. Okay? So we look at the remainder. The remainder is 2, then we look at 2. Remainder is 1, this one. Okay? Remainder 1, remainder 2, remainder 3. Do you have remainder 4? Remainder 4, we usually don't say lah. We say remainder 0 lah. Okay? Because divide by 4, takkan you have the remainder 4. So 0 remainder. Okay. So we can generate a general pattern first. So I will suggest you, maybe you can write out here. Okay. So I power n will equal to, give a curly bracket, which means piecewise. Okay. So have only 4 possible outcome. This, and this, and 1. Okay. If what happened? If the remainder is, so what does it mean by the remainder? Here the remainder refer to when you divide by 4, what is the remainder? Okay. When remainder, I just write R lah, R which means remainder. You can generate your writing. I just suggest you only, you want to generate your own writing, okay. Yeah. Okay. Okay, if R equal to 1, right? Correct. So if I means that the remainder is 1, remainder 1, then you will do the similar proof, or the power 4, and then quasar something will become 1 finally. Multiply by I, we get back I. Okay, if remainder is 2, we get -1, like just now. Just now is remainder 2, right? Remainder 2. So we will factor out. square, finally we get -1. So just now the case is in this case. Okay. Okay, now, so if r equal to 3 and the last one is r equal to 0, not 4, r means the remainder. Okay, write your own solution. Okay, so this is for us to understanding only. Okay, if we understand, then we can do very fast. Okay, so for let's say I want to do 99. 99 divided by 4, look at the remainder. What is the remainder? 3, right? This one you should know how to do. Okay, remainder is 3. So we will look at this one. So the result is -I by using this. Okay. Okay, similarly, you do for the rest. I think you already got the point already. Okay, I try to do the last one for you. Okay, last one, a very big number. So this number divide by 4. What is the remainder? 324,770 divided by 4. You get, yeah, I will show you why is it remainder. Okay. Divide by 4, you get at 1192.5, correct? Okay. So this 0.5, the decimal and the integer can separate. So what is it? 0.5. 0.5 is 2 over 4. 2 over 4. So which means this, do you still remember long division or the normal division? This is the quotient. Quotient. This is the remainder. This is the divisor. Yeah. So when you divide by 4, this is the result. Which means your remainder is 2. R equal to 2 for this case. So the answer will be -1. Okay. You try for the rest lah. Can? Wait, I answer one student. Okay, this semester 3 student ask me want to join. No need. Okay, now continue. Okay. So we settle for task 1. Task 1 is the easiest one. Okay. Anyone got problem? No. Okay. Okay, now. Oh, haven't yet. Task 1 still got one part. Okay, by observing the perhaps evaluating further example, okay, determine the possible value for I power n, okay, for any integers. Actually, you may just, this one, you can just put here because they want you to generate a general formula for in, okay? So this is your answer, okay? This is the first form, the first method to write, okay? General form. So this is what we call the general form, okay? And then there are the second method to write, depends on how you want, okay? You can write it in terms of the remainder, or you can say like this. Second method to write, still like this, but here I will say, if you know what is modulo, you can search it in Wikipedia. A much more simpler way to write is like this. N equivalent to 1 in the mod 4. This is not in your syllabus, however, which means when we divide by 4, the remainder is 1. This is another way of writing. Okay? Simpler writing. You can still choose the first method, I would say. So remainder is 2 when divided by 4. Remainder is 3 when divided by 4. Sorry, mod 4. And the last one, remainder could not be 4, so it's 0. Okay, so this is the second method to write. Okay. Okay. Remember, if your school haven't tell you to do yet, then you may wait first okay, until your school asks you to do already, then only you watch back this one. Okay, first got student ask me. Okay. Okay, now we try to do the last part, the second part, using this one, okay, which we already simplify a bit. Okay, I try to do 2 questions only. The rest you all try by yourself. Okay. Okay, now the first one, 2 multiplied by I power 10. So I power 10 using this one, 10 divided by 4, get a remainder of 2. So it's -1. 2 multiplied by -1 minus 4 multiplied by what? 49 divided by 49 divided by 4. Very easy only. You look at your okay. Okay. Tomorrow the teacher is going to check. You haven't started yet. Okay, never mind. Try to do now. Okay. Okay. Okay, 49 divided by 2 divided by 4 is 12.25. Actually, you look at the decimal, you can already know that. 25 means 1/4. So the remainder is 1. Will give you I. Okay, give you I. You know why? This one remainder is 2. This one remainder is 1. Okay. Okay, now equal to -2 minus 4i is the answer already lah. Give it in A plus BI form. Okay. Okay, now we have the next one. How to do this? Negative power. Negative power, I don't know how to divide. Okay, it's okay. We try to do this. There are um there are few methods to do lah. Okay, I will say there are few methods to do. Okay, so the first one is I -3927 can be separate to -1 multiplied by 3927, right? So by using index law, okay, okay, wait, wait, let me finish this one first, Okay, so I power -1 multiplied by I 3927, okay? So this one is by index law, Okay, now what is this result? The second one very easy because you already know 3927 divided by 4, you get remainder 3. So it becomes -I for this one. So I use a blue color to circle. Okay. Multiply by I power -1. What is it? Okay, I will write here. If you have negative power of I, anything at negative exponent, in general, if you have A power -n, which is 1/A power n. So when you have I to the -1, which means you have 1/I power 1. I power 1 means I lah. So which 1/I. 1/I. Okay, now the question comes. Okay, I ask you one thing. 1/1 equal to 1. But is 1/I equal to I? This one very interesting. Is it true or false? Why? Okay. In fact, no. Why no? Very simple to check only. If you cross multiply, 1 equal to I square equal to -1, which is always false. So this is not true. Okay, how to prove 1/I equal to what? So you do multiplication by the I. Okay. You multiply up down by I. Actually, this technique is called multiply by the conjugate, but it doesn't matter actually. Okay. For this one is a special case of the conjugate. So the upper part is I, the lower part is I square. So what is I square? I square is -1. Divide by -1. Now here only you can put the negative, become -I. This one is true. But just now 1/I equal to I, wrong. Take note. Okay. So 1/I equal to -I. Here I already show you. So we put back, we substitute back. Here, -I. Okay, what is -I multiplied by -I? Positive I square. I don't have any space already. Wait, okay. I write it down, can or not? I write it down. So meaning that I didn't do the third one. Third one you do by yourself. Okay. Equal to positive I square, which is -1. So this is the answer for the second row. Okay. Okay, I suggest you what to do. You do your working on a paper. Write your final answer on this paper only. Okay, because your working can have longer one. Can you understand? Okay, because student asked, I thought we're going to write it in a plus yi, x plus yi. Yeah, correct. X plus yi. Correct, right? If negative 4 minus 4i, also x plus yi, right? Or if you don't like, you may choose to write like this. Negative 2 plus negative 4i also can. But this one is much more simpler. Lah. Can Jun Hong? Can? Yeah. Okay, so the rest of 3 you do by yourself lah. You already know negative number become how already. Okay, so you try by yourself. Okay. I know the very difficult one is task 2, task 3, task 4. Okay, now we look at that. Okay, now task 2. Okay, very interesting, this year question. Okay, actually here, I think this one is the element of symbol. You may change it. Teacher, why I over negative 1 equal to negative I? Okay, I did not okay, maybe I could not convince you. Okay, never mind, I will try another one. Okay, see if I do this, multiply by negative 1 over negative 1. Now, is it possible for you to see already? Because the down part denominator, negative 1 multiply together become positive 1. The upper part, I multiply by negative 1 become negative I. So this is why we can have negative I. But just now cannot. You must distinguish between the case. Okay? Can Can cannot? Okay Okay. Okay, now we go this one. Okay, task 2. By substituting x equal to I theta in the series. Okay, this one is very interesting. Okay, now you will learn in your chapter 11. This is what we call the Maclaurin series. Okay, and I have given you some introduction. We can also call it power series. Okay, power series or Maclaurin series. Okay, even though you haven't learned, but it's okay. Just to let you to know, EX can have another expression as a power series like this. Okay, like this. Okay, it's an infinite one. Plus dot dot dot. Even though I didn't give you the next term, you can know the next term is what already. X power 6 over 6 factorial and so on. Okay, this is what you can know from the question. Okay. And using another 2 series and sine x and cos x. Okay, sine x is another series like this. Cos x is another series like that. Okay. Okay, so this is let's say you can imagine this is called the identity already given you lah. No need to prove, just using the result only. Okay. Okay, derive the Euler formula. Okay, we say it's the one of the most beautiful equation in mathematics. Okay, e to the I theta equal to cos theta plus I sine theta. This one you are very familiar, but this one not, right? Okay. Now we try to prove. Okay. Okay, I think I will write here for a while. Okay, now I substitute x equal to I theta in this equation. Equation 1. Okay. Okay. Substitute x equal to I theta inside into 1. Okay, into equation 1. Okay. So EI theta equal to 1 plus. So this one x become I theta already lah. I theta. Yeah. Can get okay, substitution only. Okay, substitution, then over 1 factorial plus, now, what is this? X squared. So now you substitute x become your I theta. So I theta in the bracket square. Okay, don't remember, don't forget the bracket. Bracket must have. Okay, and continue do lah. Okay, so continue do, you have power 3. So let's say they give until power 5. So we do until power 5 and see. Okay. Because first time you are using this, so I suggest you to give more. Okay. Power 4 over 4 factorial. Okay, don't stop until here. Whenever it is infinite series, I tell you already, put plus dot dot dot. Okay. Okay. Now simplify all the thing. Okay, now 1 factorial. Okay, we just leave it as 1 factorial first. Even though we know 1 factorial is 1. Just leave it only. Okay. Okay, I theta is nothing. Okay, I prefer to put like this. Theta I can. Theta I. Okay, just change the method of put on it. Okay, for the second one, you look at the green color part. I theta and then bracket square. This square give to the both I and the theta. So I square multiplied by theta square. I square is what? I square is -1, right? I square is -1. So you know by just now already. So -1 multiplied by theta square, which is negative theta square. So here you have negative negative theta square over 2 factorial. Okay, I will put it like this lah. Okay, later you will see why I want to do this. Okay, can if you don't like this one, you may also put a previous line. Okay, if you think it is too fast, then you may put one more line. You may put like this: 1 plus theta I over 1 factorial plus theta square over 2 factorial I square. Okay, can so meaning that I haven't expand the I square. Okay, plus theta power 3 over 3 factorial I power 3 and so on. Plus dot dot dot. Okay, so now you can see already I square is -1. So here become minus already lah. Minus theta square over 2 factorial. And what is I power 3? Using the result in your part A is negative I. Okay, negative I, this one. So which means you minus theta power 3 over 3 factorial multiplied by I. Okay. And what is I4? I4 is 1. So which means nothing lah. Nothing. So you just plus this one only. And what is I power 5? I power 5 return back to I. So just one I only. Okay, one I only here. Enough. I think it's enough lah, right? Okay, now how do we transform? Hey, what do we want to show? Want to show Euler formula, right? Okay, now by using, you must use both of the series. One is this one, and the other one is cos theta and the sine theta. Okay, you want to show they are equal, you using the series to show. Okay, now complex number, you separate by one is called real part, the other one called imaginary part. So what is all the real part? This one is real. This one is real. Real means don't have any I, free of the Y, free of the I. This one all don't have I. Okay, so real, real part, real part. So all are real. Okay, so we group them together. 1 minus theta square over 2 factorial plus theta 4 over 4 factorial. Okay, like this. Okay, like this first. Okay, leave it a space. Here actually I want to put plus dot dot dot. Okay, I want to put plus dot dot dot. Okay. Why? Because later you will see. Okay, another one is our imaginary part. All the term with I. Imaginary part. So you can factor out the I and the inside is your imaginary part. theta over 1 factorial, don't have I already, I already factor out, minus theta power 3 over 3 factorial plus theta power 5 over 5 factorial and plus dot dot dot. Okay. Okay, why 1 dot 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 become 2 dot dot dot? Because now I want to use another series substitution. I want to substitute sine and my cos inside. So you can see what is your sine and your cos. Okay, look at here. You not only substitute x equal to I theta inside the EX, also you substitute inside the sine and the cos. So you can see very easy only for you to see sine I theta equal to, wait, wait. Okay, sorry. For the EX1, we substitute I theta. But for the sine x1, we only substitute x equal to theta only. No need I. Okay, no need I. Because you see here don't have any I, here also don't have any I. Let's say we substitute x equal to theta. You will see it is exactly the same, right? This one and this one, correct? So the first part is your cos. This is your cos. 1 minus x squared over 2 factorial become theta squared over 2 factorial and theta power 4 over 4 factorial. Okay? Can So this one will become, I use different color. So this one, the pink color one means I substitute the real part, become cos x. You say by using the series just now. Okay? And plus, I is still here. Now, inside the purple color one, become what? Becomes sine x already, correct? By using this, sine x, using this one. Okay? Sine x. Okay, the plus dot 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 and the minus dot 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 doesn't matter much. Okay, if you really don't like, you want to put in minus, it's okay, because we can guess the next term is negative term. Okay, plus minus, something like that. Okay, but it doesn't matter. Okay, so like this only, cos x plus I sin x. Have we done the proof? Yes, we already done. Sorry, it is not x, it's actually theta. Okay, put it into theta, because we already substitute x equal to theta. Okay, by substituting x equal to theta into what formula? Let's say this is 2, let's say this is 3, right? Into 2 and 3. Okay, and we are done already. Put this one, okay, put this one, indicate we are done. Or you want to put show as the same as the question one, so you didn't put the bracket, also okay, like this. Okay, this is for the very first part. Okay. Okay, I think the next part, the IV, or the next part. Okay, I think I only do the first few, and then I give you some example. Part C in your STPM exam also got. Okay, so I think that one I won't do lah. If you really know, you can ask me. Okay. Okay, now we try to show I think the first one and the second one, or maybe the last one also. Okay, now AI, show the negative I theta 1 equal to cos theta 1 minus I sin theta 1. What is the difference? The normal formula is cos theta plus I sin theta. Now, meaning that if the theta become negative, then this one will become negative also. Okay, we try to prove it. Okay. Yeah. Okay. So this is the formula that we have already proved. So you will using this result to prove other 1, 2, 3, 4. Okay. So I will put here. This one very useful. I will put here first, meaning that I will keep using this one. Keep using this one. Give it a name, equation 4. Yeah, I will keep using equation 4. Okay, part AI. Okay, now we want E negative I theta 1 to prove it equal to this one. Okay, now what you can do is you group I negative theta 1. Group like this. Why do we group like this? Because this one will be in the form of this one. Meaning that we just substitute your theta in your equation 4 as negative theta 1. Okay? Into equation 4. And then will become so we will using this one. We will using this one. So all the theta become negative theta 1. Okay, so cos negative theta 1 plus I sine negative theta 1 like this. So this is the change. This is the thing that have already changed. Okay, this one. Okay, now you want to show as the original one, but you know from the identity, cos x equal to cos negative x equal to cos x for any x. Okay, and also sine negative x, this one is different, equal to negative sine x. This is two identity from trigonometry. So you may state these two identity, you will use these two identity. So the first one become cos positive. The second one become negative sine theta 1. Okay, so by using these two formula, okay, using this one, using this one. Okay, and rewrite again. Okay, become your equation as the question want you to show. Okay, done for the part 1. Okay, now we do for part 2. Okay, anytime you not understand, you come back. You can come back to this. Okay, because I know task 3, task 4 is more difficult. Okay, I theta 1 multiplied by EI theta 2 become plus. Okay, this one looks exactly the same as the exponent one, but you don't simply use index law. Because index law we only know for real number. This one is for complex number. We want to use Euler's formula to prove this one. Okay, try. So meaning that you can only use equation 4 to prove. You can't use other thing. But like the normal trigonometry, this one okay lah. This one very easy. Okay. This one is the thing that you have already know for real number. But you don't know whether it is true or not for complex number. Now we will show it. Not B, but it's AII. EI theta 1 multiply EI theta 2. Okay. Want to show it is equal to E power I bracket I1 theta 1 plus theta 2. Okay. We will use 2 times equation 4. We will first substitute theta as theta 1 and then theta as theta 2 into 4, right? We will use this. So if we substitute theta 1, we get cos theta 1 plus I sine theta 1. If we substitute the second one, equal to theta 2, we get cos theta 2 plus I sine theta 2. Can you understand this? We substitute the blue color one using this, the red color one using this. Okay, there are 2 different formulas. Okay. Okay, now you can expand this bracket. How to expand a bracket? 1 cos theta 1 cos theta 2 2 plus there's an I, so I usually put the I in front. It is clear that you can see it is imaginary number. Cos theta 1 sin theta 2. Third one plus I sin theta 1 cos theta 2. The last one, I square sin theta 1 sin theta 2. Okay. Okay, now separate, become real and imaginary. Okay. Now what is your real part? This is real. This is also real. Am I right? Why this is real? Because I square equal to -1. Okay. This one, go to negative 1. Okay, so you group all the real part. Group all the real part. So it become, this one no need to write. I just tell you only. Okay. Cos theta 1, cos theta 2, minus, because of the negative 1. Sin theta 1, sin theta 2. This is your real part. Now, plus your imaginary part. There's an I factor out. Always, if imaginary part, we factor out the big I. Okay? Because all got I. Cos theta 1, sin theta 2, and sin theta 1, cos theta 2. Now, maybe you are familiar with these two addition rule of trigonometric or not. Okay? You know cos minus sin is cos A plus B. Okay? Cos A plus B. Which means you apply the formula now. Okay, go back to your chapter 1. Okay, I think I don't mention already. Which part? Theta 1 plus theta 2. Remember, when this is minus, this is plus. And the balik, that is plus, then this is minus. Okay. Okay, plus I, the blue color one become, this is the addition formula for sine. Cos A sine B plus sine A cos B. Sine A plus B. Theta 1 plus theta 2. Can? This one. Like this. Okay. Now, using again formula 4 by substituting x equal to theta 1 plus theta 2, right? You see the form is the same, cos something plus I sin something. This something is theta 1 plus theta 2. So it becomes EI this lah, okay? By substituting theta as theta 1 plus theta 2 again into the equation 4. Okay, we are keep using the equation 4. You see? So you see, we are using equation 4 only lah. Not something that you already know index law. Okay. Now you only want to prove. Okay. This is for part 2. Okay. Part 3, very similar lah. I will say very similar. Can I leave it as an exercise for you? I will give you a hint for part 3. I. Okay, I will give you some hint. Okay, you can try by yourself. How to prove this one? You want to prove the divisible, right? When they divide. Okay, so become minus. Okay, so what do? Is you I do it in very simpler way. So I hope you may try to figure out what is the intermediate step and what do you need to write. Okay, in the intermediate step by using equation blah blah blah, substituting blah blah blah. So this one you must write. Cos I theta 1 plus I sin theta 1 over cos theta 2 plus I sin theta 2 by using equation what? Substituting what? Okay, until now, we use the multiply by conjugate technique. Because when the denominator is a complex number, we multiply by the conjugate, the complex conjugate of it. What does it mean by complex conjugate? Meaning that the real part is the same, but the imaginary part become minus I sin theta 2 for the denominator. And here also is the same, still theta 2. Okay, because this is actually 1. Okay, anything over anything is 1. Okay, can okay, minus, yes, correct. Okay, so the down part very easy to do only. I will not say very easy to do lah. Actually, just a matter of a square minus b square. Okay, a square minus b square. When you have a plus b, a minus b, right? This is your a. This whole thing is your b. This is your A, this is your B. I sine theta 2 is your B. So it becomes A square minus B square. Remember? So the denominator now is cos theta 2 and square. Usually this one square, we can have another simpler writing, square right at here. And we put minus, inside is I sine 2 theta, and then here we square. Okay, this one I put like this, better for you to see. It is A square minus B square. Okay, what is the upper part? Upper part, you try to show by yourself. Okay, wait, let me think. Upper part is longer a bit, but I will try to make it faster a bit. If you cannot, you look it back later. Okay. Cos theta 2. Why? Because we have two bracket multiplication bracket by bracket. So you will do, you have 4 terms. Okay, you have 4 terms. The third term, I think it's minus, minus. Okay, wait. First one, second one, okay, the third one. Okay, the order doesn't matter lah. As long as there are 4 terms, then it's okay. Last one is minus I squared. I don't have space already. The last one is sine theta 2. Okay, try to verify it. I mean, try to show it by yourself. Okay, now we do the upper part first. Similarly, we group all the real part. So real part become cos theta 2 minus I squared is actually plus already now. Plus sine theta 1 sine theta 2. Wait, A theta 2. Correct, right? I think I didn't make any mistake. Right, become plus. Okay. Now, the imaginary part, I sine theta 1 cos theta 2 minus cos theta 1 sine theta 2. And then later we will use addition formula. Okay, I solve for the upper part first, denominator letter. Okay. Okay, the upper part is, now this one again you're using addition formula, but now it's not more addition, but it's A minus B. A minus B cos theta 1 minus theta 2, it will become like this. When it is minus, it becomes plus. Remember this formula? Plus I. This one, when it is minus, for the sine one, is still minus. Sine A minus B. Okay? And then, now it's okay for the upper part. Now the lower part, cos square minus I. Okay, I will show you this one. This one is actually I square sine theta 2 here square. I square means negative 1, right? But this is minus minus. So when you have 2 minus, it becomes plus again. So can you see why it finally become plus? There are 2 minus here. Again, by using what formula? You know that identity, this one always 1. Actually, I tell you do by yourself, but actually I solved most of the part already. I mean, you just write the important words okay, by your own. So finally, again, apply equation 4, substituting theta 1 minus theta 2 inside the equation 4, we get back as what we want. Write all the things that you need, that is needed. This is only called a mathematical presentation. Okay? Part 3. Okay, we're done for part 3. Now we will go for the last part. Last part is De Morey theorem, right? De Morey theorem for the integer power case. use the series to show. Sorry. Use the Euler's formula to show. This one, excuse me. Okay, this one, what do you do? Okay, wait. Okay, for the general case, when we have power n, we try to show it is equal to this one. This one very easy only, I will do for you. But very easy doesn't mean that it is easy to think. The work few steps on it. Okay, but how to write, it is important. You start from this, correct? Okay, now you want to prove De Morris theorem by using Euler's formula, again, equation 4. Now, applying equation 4 by substituting theta equal to theta 1 into 4. Okay, I just simply write like this, meaning that you substitute this one into the 4. Okay, so become e to the I theta 1 power n, right? Power n. Okay, now, excuse me. Okay, now what you are using, assume you know the index law for the complex number, okay? Which means when you have e power a multiply in the bracket, power b again, actually is a multiply b. This is the index law. So I theta 1 multiplied by n, right? Okay, next step. You want to prove n theta 1. So if okay, I group the n theta 1 together, multiply by I, or I put a bracket, I, like this. Because finally, I want to show it is equal to cos n theta 1 sine n theta 2. So if I want that, I use again formula 4, equation 4. But now here I substitute theta as n theta 1 into the equation 4. So I get cos n theta 1 bracket plus I sine n theta 1. Okay, so this is the whole proof. Okay, anything want to ask? 4 equation, 4 proof here. Okay. Okay, I think okay, part B and part C, I will tell you very similar only. Very similar only, like how I did for this one, just the balikan only. Okay. One thing I dislike for this question paper is that the part A and part B actually, you use part A to prove part B, you use part B to prove part A. It's like circular argument. That's why I don't like the question paper for this, but that is my opinion. But it's still, you can use the upper one to prove the lower one. Because the part B actually is the addition formula, but later in the derivation of part A, I use addition formula to prove. Now I use this one to prove. Okay, in mathematics, we call this circular argument. Actually, it's invalid one, but it's okay lah for you. You still can use that one to prove this one. Okay, doesn't matter. So you try to use part A to prove part B. This one you can try by your own. Part C also same. Part C, change into polar form and then use De Morris theorem. Okay, I guess I already did many times for you already lah. If you don't know, you can try it first. Okay, then you ask me lah. I think today our main point is still task 3 and task 4. Okay, very difficult question. Now I will go to it. Okay. So they want to try by yourself. Okay, now task 3. Actually, here is a only today I noticed. Here is a new concept for you. Okay, which you will learn in chapter 5 only. It's what we call the parametric equation. Parametric equation. So I feel a bit unfair for you lah, because I also didn't notice. But it is okay. Later on, we will still learn. But for now, I will teach you what to do. Okay. So meaning that you have a function called zt. T is what we call the parameter. Z is what the parametric function. Okay. So meaning that this t is a variable. Sorry, yeah, independent variable changing. Okay. And z depend on t. The value of z depend on t. Okay. If you don't understand, never mind. We still proceed. Okay. So they want us to what to let z equal to this value a plus b I multiplied by t. Usually t denote for the parameter. Okay, t can stand for time and any other thing. Okay, where t greater equal to 0 to be a parametric equation of a curve in the complex plan. Discuss the modulus zt, meaning that the modulus, okay, the absolute value, the modulus of a complex number. When a greater than 0 and a less than 0, meaning that different case, you can have so many cases, okay, and for various values of t. Okay, now, okay, I will give you one simple example to demonstrate you what does it mean by parametric equation. Okay, you can take note of it. Okay, let's say, okay, now, let's say y equal to t, x equal to negative t, for example. For example, okay, this is called a parametric equation. Equations, okay, and the t is called a parameter. If I want to plot this parametric curve on the plane, the whole thing is called a parametric curve, okay, on the plane. So what I do is, let's say, maybe I can put a box like this. When your t value equal to what, x will become what, y will become what, something like this. Okay, let us just give few numbers. Let's say, what is your value of x and y when t equal to 0? When t equal to 0, x is negative 0, right? Which is still 0. You're using this formula, okay? And y is equal to t, so which is also 0. Okay. Okay, so meaning that when t equal to 0, you have x equal to 0, y equal to 0. You can plot this point on the plane. Here is origin 0, 0, when t equal to 0. When t equal to 0. So this is your point. Okay, you have already 1 point. Now let's plot 2 more points, can or not? So let's say I plot 1. When t equal to 1, what is your x? Your x is negative 1, because negative t, and your y is t, so which is 1. Okay, now look at this. When x is negative 1, y is 1, the coordinate is negative 1, 1. Where is this point? The x value is negative, y value is positive. It is over here, right? Am I right? It is over here, this point. Okay, so this is when t equal to 1. Okay, agak here, negative 1, positive 1. All right, so take one more value. Let's say I put negative 2. Okay, t can be anything. Negative can also, but in this case, it is positive. And anyway, let's say it is negative 2. So your x will become negative of negative 2 using this formula. So become negative 2, meaning that positive 2. Your y is the same as your t, so negative 2. So 2, negative 2 is your point on the plane. So where is it? 2, negative 2. Here, 2, here, negative 2. You plot a point here. So this is the point when t equal to negative 2, like this. Okay, sounds like what? Looks like what? Okay, looks like what? If you continue to plot all the points, you will finally observe that all the points will lie on the line, like this. If you continue to plot all the points will become like this. Okay. Now, meaning that this line is actually what when we use Cartesian equation. Okay. It is how to prove. Okay. Y equal to t, x equal to negative t. If we want to eliminate t, what does it mean by eliminate? We want to make t disappear. We don't want t. Okay, so how? Equation 1, equation 2. Okay, substitute the t equal to y. Substitute t equal to y into the equation 2. Sub 1 into 2. X equal to negative y, right? Because this one, substitute here. Okay, become negative y. And you rearrange a bit, become y equal to negative x. So actually, y equal to negative x is the curve. Okay, and when we use a parameter t, then this one become parametric equation. So a line, a curve, any curve can have two ways of representing. The first one is called the Cartesian equation, meaning that in terms of x and y only. Okay. The second one is called the parametric equation, meaning that we introduce a new variable t, and both of them depends on t. It's what we call parametric equation. Anyway, this is the introduction only, and I find it very useful for you. You can take note of this first. In chapter 5, it will be helpful also to some certain extent. Okay. Now we go back to our question. So this one very difficult. Straight away become very difficult. Okay, ZT is something like this. Now become complex number already. Okay. What does it mean by complex plane? Argand diagram. Okay, meaning that let this one to be a parametric equation on Argand diagram. Okay. Okay. Now we will do few things. Okay. First, I think I will show you why e to the power of a plus bit is equal to that very long one, right? Okay, I will show you this one first. Even though they didn't ask us to show, but I will try to show you first why is it true. Okay. Okay, I will show here. I found it very important also. Why they didn't ask to show, I don't know. Okay, now from the right hand side, left hand side to the right hand side, E A plus B I T. Okay, now you were using Euler formula. Okay. Okay, now T by distributive law, give to A, give to B. So become AT, become BTI or BIT lah, whatever. Okay. Now by index law say when you plus in the exponent, become multiplied. Okay, of the two numbers, DTI. Okay. Now EAT already settled because EAT is this one, what we want. We want to show that this one is the exactly same as this one. So we somehow need to use the Euler's formula. Okay. Now, how can you change this one? E to the power of I, and then what is left? BT, correct? By using associative, change the order only, make I here, make BT here. Why I make it like this? I want to use the equation 4, Euler's formula. Now I can use already. By substituting theta equal to BT, right, in equation 4. I still refer to the first equation 4, the one that I mentioned. Into equation 4. So this one becomes cos BT plus I sine BT. Okay. Now we are done. Okay, we already showed that it's the same as the formula, equal to the right hand side. Okay. Anyway, this is just for you, for your reasoning only. Why is the right hand side equal to the left hand side one? Okay. Okay, now we will continue to do this one. Okay. Let's don't look at the bigger one first lah. Let's say we only focus on this one. What is this? This is the inside one. Okay, inside the bracket one, meaning that your e power bi. This is e power bi, if you notice. Okay. Okay, let's say we want to plot e power bi first. Okay, which means this thing lah. When b greater than 0 or b smaller than 0. Okay, for different case. So b equal to what? You can choose your own value lah. For easy, I will choose 1. And I will choose -1 for negative number. Okay, it's the most simplest case. Let's try to do it. Meaning that when b equal to 1, what is this equation become? Cos t plus I sin t. Am I correct? Because b equal to 1. Okay. Okay, now they already prepared the table for you. Why you need table? Because to plot a parametric equation, as I mentioned just now, when t equal to what, x equal to what, y equal to what, and now you only have z only, meaning that you will plot when t equal to 0, what is this value equal to? Okay, meaning that I will substitute t equal to 0 into this equation. Okay, this equation maybe I put 5 for you to reference only. You don't need to write. Okay, meaning that I will substitute t equal to 0 into equation 5 here. Okay, sub t equal to 0 into 5. This is the meaning. So cos 0 plus I sin 0. What does it equal to? Sin 0, 0, cos 0, 1. So which is 1. Okay. Okay, next. Pi over 4. Substitute t equal to pi over 4 into equation 5. Cos pi over 4 plus I sin pi over 4. What is the value? Square root 2 over 2. Both are square root 2 over 2. Positive. Correct? You can choose any other value if you don't like b equal to 1. But it will be the value will be very fancy. That's why I don't like. Okay. Pi over 2. Cos pi over 2. I sin pi over 2. So what is pi over 2? Which one is 0? This one becomes 0. This one become 1, right? So 1i become I only. Okay. Just put 1, just equal to I. Okay, equal to I. Should know why. Okay, now same thing lah. Actually, cos what plus I sin what is cis. Okay, cis anything. So pi become -1. You can verify by yourself. Okay, try to verify by yourself. Substitute t equal to pi into equation 5. -1 and you get -I. Finally, you get 1. Okay. Try to see it. Okay. When b less than 0, so you choose -1. Now no more equation 5. You generate another equation 6, let's say. So when b equal to -1, this one become -t already, plus I sin -t already. Okay. And now you substitute. So meaning that this is equation 6. Correct? So which means you substitute t equal to 0 into 6. Okay. And you will still obtain cos 0 plus I sin 0. Still -0, 0. This one is still 1. Cos -0 plus I sin -0. 1. For the second one, you substitute pi over 4. But notice here you already have negative. Negative pi over 4 plus I sin -pi over 4. What value is this? Let me think. You can use calculator also. You don't want to use calculator also can. Just imagine on the complex plane, uh the direction here is now to the quadrant 4, and your x is positive, your y is negative. Maybe I show like this, will have the balik or not. I am not sure. Okay. The cos one is positive, so positive square root 2 over 2 minus I square root 2 over 2. The y value is changing. Okay. Try to do the rest of it. I think this one is negative I. This is negative 1. This is positive I. This is positive 1. Okay. Remember how to do? I told you, if you want to use your calculator, so can just how? Just oops, yeah. Let me zoom. If I want to use my calculator, meaning that. Yeah. Hold on. Um, wait, 1 minute rest. Okay. Can I want to calculator. Okay, see whether I can do or not. Can you all see my another screen here? I hope you all can see. But I know it's very blur. No, cannot. Okay. It's not another screen. Actually, I think you need to put another camera. Look at another camera. I'm showing my calculator right now. Can you put the how to say, the view into many grids so that you can see other people camera also? Very difficult. Because my license also haven't done. Okay, anyway, use the function key only. Okay. Use the function key only. Can you see now? Yes, seeing. Okay. So how to use a function key? Wait, I want to, but I think it's very, very small. Maybe you need to pin my calculator. Okay. So meaning that you put complex, try to pin complex first. So you enter, let's say equation 6, right? Cos negative t means you press alpha x, okay, and then close bracket, plus I is here, engineering symbol eng, plus I sine negative alpha x, close bracket. So this is equation 6. Okay. Now you press calculate, and you press, let's say what is your value? Let's say 0. Then you should give you 1. Okay. And then you press calculate. Let's say pi over 4. Okay. Pi over 4 equal and pi over 4. Is it correct? Where this is what? Pi over 4. Let me see it again. Yeah, correct, right? Why become like this? Oh, okay, sorry. I'm in degree mode, sorry. Okay, press setup angle unit to make it in radian. Why suddenly I'm in degree mode? You should get this one. Remember, this is the latest calculator, 570EX. I will always using this one in the demonstrating because this is non-programmable calculator, and it's the best among all the series. Can give you the cert form. So which means this one, okay? This one. Okay? Okay, now I will stop sharing. So you all know how to use the calculator function key. For the new student also same. Okay? Can you all see now how to use the function key? And you can easily substitute any value. Let's say you don't like this one, maybe you put b equal to any other thing. Okay, and then you put 6. Can give you another value also. This is the value. Okay. Yeah, I will stop sharing this one now. Okay, now we'll go back here. Okay, look back at my iPad. I think next week I will settle the calculator thing. Okay, sorry for right now. Okay, wait, let me unpin my this one. Inside bracket. Inside bracket? What does it mean? What do you mean inside bracket? Wait,
Sure.
yes.
Just now you press the calculator, right? Y inside is negative x.
Oh, that one is equation 6, not equation 5. Because cos negative t, this one. Can see? If you want to put equation 5, then you don't have the negative, meaning that x only. Okay? Wait, if you can pin it, can or not? Wait, how to share content. So if you pin my camera just now, you have to press the pin screen. Sorry, the share screen. Okay. Okay, now we go back here and then we will look at here. Okay, we already settled this part. This is the blue color part here. What is the red color part? This one. Okay, now we try to see what is this red color part. Okay. Before this, actually, I forgot to discuss one thing, which is this one. What is the modulus of zt when a greater 0, a less than 0? Okay, a greater 0, less than 0, it doesn't matter. Okay, let us just look at the zt. Okay, zt only. Okay, we try to find what is our zt. So, I do a new paper. Okay, now, the modulus zt. What is your zt? Zt is this whole thing. At also included the bracketing cos pt plus I sine pt, right? And I want to find the modulus. And what does it mean by modulus? In complex number, a modulus of x plus yi, okay, a complex number, is you square the real part and you square the imaginary part, you take the square root. This is the definition of modulus. So you need to identify first which is your real part, which is your imaginary part. Now, we multiply this one to here by using distributive. Distribute first, like this, plus. Okay, maybe I put the I. I always like to put the I out there. Easy to see it is imaginary. Okay? Okay, Ken? Okay, why I do like this? Meaning that I want to find the modulus of this. Okay? The modulus of zt is equal to this one. Now, here is very easy for you to see that this is the real part. And this is the imaginary part. Remember, imaginary part not included the I because I means it is imaginary. The part means exclude the I inside it. Okay? Okay, now continue. Okay, meaning that real part square, this part cos pt square plus imaginary part square. And you take the square root of the number like this. Okay, now simplify lah. Simplify. See what is your number. Okay, very easy only. For let's say for we focus on this. This square will give to here, will give to here. Okay. The also will become like distributive one. Okay, so EAT square cos BT square plus EAT square sin BT square. This one very lengthy, but do step by step. You will know, you won't get wrong. Okay, this one formula can I cancel already? Okay, you should know this one. Okay, okay, continue. Okay, I already mentioned to you e power something bracket and square. Okay, it's the same as AT multiplied by 2. Okay, AT multiplied by 2. Right? And then, excuse me, and then AT multiplied by 2, meaning that simple right 2AT, can 2AT, you should know lah, in one step. And then cos square BT is the is a shorthand for square of cos. Same thing for this 280 sine square BT, and then square root of this one. Okay, now here you have this one did appear, this one also appear. They are exactly the same, right? We try to factor out them first. Okay, we try to factor out. Now we want to simplify this formula. 2AT E2AT in the bracket. So what is inside? Cos BT plus sine square BT, and then square root. Okay, now you know anything, any cos square plus any sine square will equal to 1, no matter inside is what. Okay, for any number. Okay, BT is any number, whatever. As long as they are the same, then this whole thing will become 1, the identity. A very big identity. So this equal to 1. Okay, and then here we still have E2AT. Okay, actually, what does it mean by square root? Square root means the whole thing multiply to take the power to the 1/2, correct? This is the meaning of square root. Okay. Okay, now continue. Very easy only. E multiplied by AT, E power 2AT multiplied by 1 is still the same. And then 1/2, actually by the index law, you can just see that it is multiplied by 1/2. Finally become EAT. Enough. Done. Okay, this is the value of modulus ZT. Okay, so this is the proof. Okay, after we have done, they want to ask us what happened when a greater than 0 and what happened when a less than 0. Okay, there are two cases. Okay, now we look at here. We discuss one by one. Okay, when a greater than 0, what do you see for this? Okay, what do you see for this? T is something changing. I already told you something changing, meaning that it's a variable. Okay, variable meaning that you can look it as a function. E to the power of x, exponential function. When a greater than 0, still remember what is the shape of it? Maybe we can draw a graph. Okay, remember all these things you can put in your solution. Okay, okay. So when a greater than 0 is an exponential function. Okay, having the graph is an exponential function having the graph. What's the pattern? From negative is 0 and then go to the upper part. Okay, this is the shape of the graph. When a greater than 0. Okay, go to look at your graphing calculator or what, or look back in your chapter 1 exponential function. Okay, so this is the shape, and here the value is 1. Okay, the down part is t. Okay, here is y. This is the function of y equal to EAT. Okay, okay. This is the function. Meaning that, what does it mean? Meaning that when t increase, your modulus, or we say the length, modulus, the length of the complex number in the complex plane keep increasing. Okay, geometrically. Okay. However, in this question, they already mentioned t only greater than 0, right? T only greater than 0. Here, where t greater than 0. Can highlight here. So meaning that if you want to draw the function, you did not draw for this part also okay. Meaning that here you can cancel, also never mind. But you want to put also never mind. Better cancel because in this case, right, we only have this. So this is the function. Okay, this is the modulus. It start at 1. Okay, what happened when it is negative? Still remember the graph? Okay, the same thing, but symmetrical about y-axis. So become, you will have the graph like this. Okay, having asymptote x-axis, and can you see that? And cannot see, okay. But also same thing, we only discuss for t greater than 0, so we can cancel the part where t is less than 0. So here we don't want, okay? So we only want this part. Now this is the function. Y equal to E A T. Okay, when a less than 0, okay, for example, I give you one example. Can you plot E negative T? E negative T meaning that E negative X it's the same thing. E negative X, the graph is look like this, right? All right. And if you put A equal to 1, so meaning that EX or ET, the graph will look like this. Okay, growing up. The other one is decreasing. Okay. Take note of the difference. That much only you need to write. Okay. You just say that. What's the difference? What is the difference? Maybe this one you can put. You just say that the graph looks like this. Okay. The graph of y equal to EAT. And we say this is increasing. And we say the other one is decreasing. Can you know what is increasing, decreasing? By looking at the graph is very easy only. Okay. Okay, now next part. We want to sketch the point in the second column. Wait. Have we done? Have we done already? Okay, we haven't done. Okay. We try to plot the here, right? The ZT. Here, all the other values. Okay, ZT equal to EAT multiplied by this one. Okay, multiplied by this one. Okay, the blue color one you already have, but the red color one you haven't got yet. Now maybe I think you can put excuse me. You can put your EAT value maybe here, or maybe the last part also can. Okay, just as extra lah, because you want to know what is your value when a equal to 1 and when a equal to -1. Can? And you want to find what is your value of EAT. Here don't have lah. Here don't have. We start from here. Okay, it's better. Usually we do the box one. Okay, it's easier. Okay, now what's the first value? When t equal to 0, you substitute, meaning that you substitute t equal to 0 in this one. I refer this as equation 7. You don't write, so never mind. Substitute t equal to 0 into equation 7. E power 0 equal to 1. So the modulus is 1 now. Okay. Okay, look for the other case. When t equal to pi over 4, correct? Substitute e power pi over 4. What is the value of this? Okay, e power 4 may be enough lah, right? But in the sketching, okay, later on you will see you need to sketch. So maybe you need approximately equal value lah, approximate value. Okay, so e power pi over 4, you know how to press, don't press wrongly. You should get 2.19, around 2.19. Okay. Okay, what is e pi over 2? Around 4.18. This one 4.81, sorry. I think correct, am I right? 4.81. Okay, I give you the rest of the value. You may catatkan dulu, later you prove it by yourself. You try to verify it by your calculator, correct? 111.32, 535.49. You see, the value keep increasing very super crazy fast. Take note of the value. Okay, write it down first. Later you try to find by yourself. Okay, you see, when a greater than 0 is an increasing function. All the value are increasing. Okay, when a is less than, okay, wait. I want you to do a equal to -1 by yourself. Finally, you want to get it is decreasing, meaning that wait. This equation 7 actually just t only. Can you understand? Do you understand that? So et, meaning that we substitute t equal to 0 into the et function only. And similar for this, when a equal to -1, so here become -t. So this is your equation 8. For example, you substitute 0 into equation 8. Okay. You also get 1. E power -0 also get 1. Okay, I will give you the second value, and the rest of value you find by yourself. Second value is -pi over 4, right? E power -pi over 4. Around 0.4. How many decimal value I to give? I think this one you may give more, because later you will find that it is very, very small. So maybe you can give more value. 4559 I give 4 value. Okay, 4 dp. Find the rest of it, okay, by yourself. So I only show until here. Now I want to continue already, because I have no time. Okay, do it by yourself. Okay, now we go to here. Okay, we want to find a equal to 1. So meaning that I will multiply. Okay, let's put our value first. B greater than 0, we put 1. Here we put -1. Here we put 1. Here we put -1. So meaning that for this row, for this column, the first value I will multiply my AT, which is 1. Can you see that? 1. Okay, maybe I use a laser pen. You multiply this one by this one. Okay, 1 multiplied by 1. Because B greater than 0 and A is equal to 1, right? So you multiply these two numbers. You get 1 multiply 1 equal to 1. Okay. Okay, the next one. This multiply by this. Okay. 2.19 multiplied by the square root something. Okay, copy. 2.19 multiply square root 2 over 2 plus I square root 2 over 2. Okay, like this. Okay, equal to what? Okay, you can try to find using calculator. 2.19 multiply square root 2 over 2. 1.59 I will just give some approximate number. Oh, sorry, 1.55. And plus 1.55. The number is the same, I. Okay. 1.55 plus 1.55 I. Okay. Okay. I will and then also same, right? So also same. This number multiplied by this number. that is I only multiplied by 4.18, meaning that will become 4.18 I. Yeah, 4.81 I. Okay, must write 2.19. I cannot write E pi over 4. You can actually, but when we want to sketch, it is better to have an approximation number. You can have that in this table, it's okay. But when you sketch, you must know the number. Can also. And that one will be more exact, okay, more accurate. But to sketch, maybe I will put this one first. Okay. Okay, now continue. So the rest is the same only, right? 23.14, and then you add a negative. Why? Because here got negative. Okay. 111.32 I. 5 is the same thing, multiply by 1. Okay. Okay. You do the rest of it. How to do? Let's say for b less than 1, you multiply this column by which one? A equal to 1, right? So with this column, okay? So you look at the condition, A equal to 1, B less than 0. So you multiply B less than 0 and A equal to 1. This row multiply this row. Okay? Column, sorry, I mean. Okay? And the rest also same, A equal negative 1. So you multiply this column by here and here for these two. Okay? So to do the rest for yourself, I only demonstrate the first one for you. Okay? Sketch the point in the second column. Okay, we do A, we do A first. Part A, sketch the point in the second column of the above table and Argand diagram and trace the curve as t increases. Observe your pattern. Okay. Okay. Actually, it means you plot on Argand diagram. Okay, you plot an Argand diagram. This is your Argand diagram. I put very big. I want you to see. Argand diagram, real part, imaginary part. Okay, now I plot all the values. Second column mean what? This is the first column, right? Actually, I also thinking this one very long time. What is the second column? I think second column is this . Okay, I think it's this. Okay, we try to plot all the point or sketch all the point in the second column. Okay, meaning that 1, right? 1. I put 1 . Okay, remember so just now at a Cartesian plan we plot the t. Now for different value of t, we plot in a complex plan. Okay. Now here is 1. Here is 1. So meaning that I will have a point here. Okay. You can take note. This is when t equal to 0. This one I don't need to write. You want to write also can. Okay. When t equal to 0. Maybe for the first time you can write also. Okay. To show how you draw. Okay. You can write also. Okay. Now what else value? Square root 2 over 2 plus square root 2 over 2i, right? So both of the number are square root 2 over 2. Square root 2 over 2 is smaller than one number. So maybe here. Okay. And then the value is here. Okay. Okay. And this is the value when t equal to pi over 4. Okay. And plot all the rest of the value here. Yeah, another one, right? I, am I correct? This is your I, I at the imaginary axis, 1 meaning that 1 multiplied by I. Okay, imagine imaginary as unit I. Okay, so this is when t equal to pi over 2, right? And what else value? Here, right? If I'm not mistaken, and here, right? If I'm not mistaken. Okay. Pi only, 3 pi over 2. And last one, hey, sorry, you can't see. Okay, and last one, you go back to 1 already, correct? Go back to 1, again. Go back to 1. So here, actually, we have 2 points. Okay, another one is t equal to 2 pi. Here, also same. Okay, which means you have a duplicate points. Okay. Okay, now what the question asks you, they say observe the pattern. What do you think this one is? looks like a circle. Okay, looks like a circle, right? In fact, it is really a circle, meaning that you give some other values of t. I simply give one value lah. Okay, see whether it is true or not. They say you can add more value to verify the pattern, right? So let's say I put my t as, uh put my t as maybe some any random number lah. Okay, not even the perfect pi multiple. You can put maybe 1.5. No need to put pi. No need to put pi. Just 1.5 only. The number is cos 1.5, 0.07, and sine 1.5, which is plus 0.997i. Okay, very weird number is okay. 0.07 very small, 0.99 very big. Okay, it is about here, I think. 0.07 and here 0.99. So meaning that here, right? Okay, if you complete the whole thing, you become a circle. Okay, let's put okay, not only the value between here, you can put more than 2 pi also can, because t greater than 0, right? You can put any value. Let's say I want to put 10. I substitute t equal to 10. Cos 10 is negative 0.84, and sine 10 is minus 0.54i. This value, when you plot into the Argand diagram, also negative 0.84, negative 0.54. About here lah, right? So agak-agak here. Okay, like this. So if you put whatever value also, if you end up, it lies on a circle. Okay, lies on a circle. So maybe you can draw a circle to verify the pattern. Like this, passing through all the point. Okay, my one may be not that perfect lah, but you should be able to see that it is correct lah. Okay, my one is not that perfect, so you can try by your own. Because I'm human, so I cannot make a perfect one. So you may get a better one using graphing calculator or whatever. Okay, like this, okay, like this, can. Okay, so meaning that end up be a circle. Okay, now if you observe, if t increase, right? Just now we are from here and then we go up, right? We go up, and then touch this point, touch this point, touch this one, touch this one, touch this one, and then go back here. And then you will see that it will again and again do a circle like this. Okay. So what can we say? We can say this is the circle, is the first thing. We can comment, I will comment, right? What conclusion can you draw, right? So the conclusion you can draw. Okay, first, it is a circle. Circle, what is the radius? 1, correct? Circle with radius 1. And then center is at origin. You remember, this one is your SPM thing already. However, you will still do it with chapter 5. A circle must have 2 important information. Radius, how many? Center, where? And center is at origin. 0, 0. Okay. Center 0, 0 or center origin. Okay. Maybe you say 0 is better. Origin. Okay, origin or 0. This is conclusion 1. And you can have your next conclusion also. Second thing, this one rolls up like this, right? Like this, and then go like this, go like this, go like this, go like this. Okay. What is this type of circle? We have 2 types of circles. Look at your clock. Your clock will spin like how? This one is anti, right? Anti-clockwise. So this trace, you can say the direction of the trace is anti-clockwise. okay, is anti-clockwise. Clockwise, anti-clockwise. Huh? Okay, can I? Okay, okay, done for this part already lah. Okay, now I want you to verify by yourself the second column, the third column, right? They want you to repeat. For third column, meaning that you will draw again for this one. And much more similar way, however, the conclusion is different. Still a circle, you need still a circle like that. That kind of circle, we have another name. We say it's a unit circle. Unit circle simply means that radius 1 and origin center. Unit circle. But the direction is different. You should be verified that the second one, direction is clockwise for the third column. Okay, with the Bartlett one. Okay, you look at the values also, you can know lah. One then you go there, negative I, negative like that. Okay, the Bartlett lah, the direction. Okay, okay, this one you do by yourself. Okay, now we continue to do part B. I don't think whether it is possible to finish all the things or not in one day. If not, I think I will not make extra class already. I want to settle one in one day. Maybe I will continue to say, for those who want to leave early, you can leave early, but I will continue to discuss the last part. Okay, if you're okay, then you stay. If you're not okay, tomorrow you want to wake up early, then you may go to sleep now lah. Okay, I will have the recording and you may watch back lah. Okay, now we look at the part B. Sketch and trace the curve ZT as t increases. Okay, so meaning that ZT, which is the value here. So you have 1, 2, 3, 4, right? So meaning that the fourth column, fifth column, sixth column, and seventh column. Okay, just now you did the second and third. Now you want to do for the rest, correct? Yeah, A equal to 1, B equal to 0. I will still demonstrate the first one only for you. The rest you demonstrate by yourself. Okay, look it by yourself. Okay, now what happened? I do for the first one only lah. A equal to 1, B greater than 0. Okay, because I already give the value, so still in a complex plane, REIM. Later I will tell you to use calculator. I think graphical calculator maybe is better. So remember, you can include some picture from the graphical calculator. Graphing calculator is okay, meaning that you screenshot or whatever from the calculator you did, and then you print. Also okay. However, still refer to your teacher because anything I say, you must refer to your teacher also. So if let's say your teacher don't like this one, then you must maybe somehow follow her instruction or his instruction. Okay. Today, what I give is just the suggested solution only. In fact, MPN won't give the answer for this one. I did it by my own, and then I give you the suggested answer. This is what I think lah. Okay, for this whole thing, for this whole question. Okay, continue. Okay, we do the first one. Okay, just now I plot. I plot. So 1 multiplied by 1, correct? So it's 1. Okay, so now I will put 1, right? So I will plot this all number. Remember? Okay, maybe I copy first. No, I forgot. Okay, I want to plot this all number. Okay, the first one is 1. So similarly, same lah. Okay, but this one, try to make a smaller scale. Because the largest one is 535.49. So maybe the largest one you give until here lah. Let's say. So we put here 545.49. So here is the last point, correct? The last point. Okay, put here. Okay, now the first point, 1, very small only compared to the 545. So you will just put here lah, maybe 1. sketch only lah. If in the reality, it really cannot see one, okay? Not even have a space. But in sketching, we can make it. Okay, but later on you want to use a calculator, it will be different story lah. Okay, now continue to plot. So the first one is 1.55 and 1.55, right? So here 1.55 and here 1.55 I. So here. Okay. And 4.18 I. I only, purely imaginary. So here. I don't want to put so much. Okay, maybe here 4.81. And next, negative 23.14. Maybe here. Negative real number here. Next, negative 111. This one bigger already, like maybe you can put here. Okay, 111. Remember, all these values are very small compared to the 500. Okay, now sketch the trace, meaning that from the lowest, from the first one, draw a line almost freehand to the largest one. What can you see? What type of the shape is this? This one is the smallest one, correct? So draw like this, intersect all of the point, intersect, okay. Intersect all of the point. Cannot, this one, OCD. Okay, must intersect. Okay, I stop here. Okay, continue, drop. Not that perfect. Draw again. Or maybe how? Can you suggest me any? Okay, can just agak only. Okay, later I will show you the real one. Okay, I will show you the real one. Okay, these are all your. So it looks like this. What is the shape? Something like this. So meaning that if I give you, so this is the first few values. So the t increasing, you know that this curve become larger and larger. Alright. Okay. Actually, the modulus, what does it mean by modulus? Modulus meaning that if you look at here, the first point from origin to here, the distance is 1. And then next, this distance is 2 point something, as what you have shown already just now. And this distance 4.81 and continue increasing 23 something, 111, and then 500. So if you increase in an exponential growth, very super crazy fast. Okay, so this is what the thing. Okay, now I tell you how to use calculator to draw, correct? Can? Okay, now like this I suggest you to draw one time using a paper and using your hand. Okay, if not, too depends on the technology already. Okay, or you may draw few of it. You may try to guess the picture, but then only you try to use calculator. Now I will teach you how to use calculator. So use Desmo, open your Desmo, DESMO, the green color one. This is the favorite. This is my favorite calculator. Okay, how to draw a parametric curve? Okay, now, what is your parametric curve? For this case, is A equal to 1, B greater than 0, right? We choose B equal to 1. So A, B also equal to 1. So this ZT equal to, rewrite it, EAT, so E multiply T, 1 multiply T, and then cos B is 1, so cos T plus I sine T, right? Like this, okay. Remember this technique, okay, remember this technique, how to draw your, how to use calculator. Okay, ET cos T multiplied by I sine T lah. I can use distributive, become like this. Cos T, I like to give the I outside lah, for you to easy to see that this is imaginary part. Okay, so here you have two parts, real part and your imaginary part, correct? Okay, looks, if you want to plot these all values on a plan, Argand diagram, the real part actually correspond to your X value. Am I right? And your imaginary part actually correspond to your Y, right? So all the X value are your X coordinate, and all the e power t sine t is your Y coordinate. And I tell you how to use this one. Okay, put a bracket. Do together with me, lah. Okay. Put a bracket, and then just insert whatever it is look like. Okay, you go to here, A, B, C. And I know if you are using phone, it's different one. Okay, maybe later you can try using your laptop. It's better. Or iPad. Okay, better. So E power, you know how to put your power? Here, I cannot show. The 1, 2, 3, 4 here. Okay. So E power, the A power B layer. Okay, E power T, right? Am I right? Here. So you just put T only. If it is T, just put T. Even though it looks like this, never mind. Later I will tell you how to do. Okay, and then cos, correct? Cos, you want to press COS also can. You can press the function here. I mean in Chinese mode, the function here. Find the cos here. Oh, sorry. Delete it first because the typing thing is still on the exponent. So you press next button. You press the arrow next button to give it down, make it down in the base mode. Now only press your function, press cos. So ET cos what? Cos t, right? Am I right? ET cos t, Okay, let me go back. Correct, ET cos t. Here I want to put ET cos t. So meaning that ET cos t, comma, I no need because I already told you. If I want to plot something, the calculator will give you nothing. And the Y value is ET sine t. Okay, I value is ET sine t. Okay, and then after you have done this, you put a comma. E, similarly, ET, and then sine t. Okay. If you don't know how to do this one, you can also touch up. Or if you are using laptop, you can use the arrow button. Okay, to adjust your value. So you should have something like this. Okay. And now you can set your t value. Look, down there have a t. Actually, calculator can understand you want to plot a parameter equation, parameter curve. So now they say t is from greater to 0, right? So t greater than 0, meaning that you can plot when t is 0 until very big number. Okay, I simply insert a number lah. Let's say I put 99. Okay, enough. 99. Okay, and then you may close it. You may see is that consistent with what we have drawn? First value is at 1, correct? It starts at 1. 1, 0 is the starting point. And then goes like this. And then just now I say passing through 4.81. True, see here passing through 4.81. And then you it's not zoom lah, okay? You make it smaller, see what happened. Correct? Is it all true? Here is negative, intersect another x-axis at 20 something, 23 something. And then down here, 111. And then you continue to see here, I think it's 500, right? 500 something, right? Then it should be like that. And then you can continue to see what the pattern. You can continue to zoom out, okay? And then you can zoom in. And this is the pattern, I will say. So maybe you can take a screenshot or whatever. You say, okay, teacher, this one, okay, using calculator, okay, and give a picture, something like that. So I will put it, I will attach this one, okay, I will attach this one. Do you need a formula? I think I give you a formula also, give a formula. Okay, later I will share. If you cannot, you can ask me. But I want you to really to try by your own. I will not share the. I will not share the calculator. Calculator can share one, but I think I don't want to share. If you really cannot, then you ask me. Try to plot for the other four things also. Okay. I think the time is already there. If you want to go, you may go now. Okay. See you next day. Okay. So I will continue to discuss the last part. Can? Yeah. Yeah. Oh wait. Wait. Give me 1 minute. Okay, I'll try to discuss it in a very faster way lah. Okay, in a very faster mode. Okay, so meaning that B part BI and part BII, you can try it by yourself. Okay, all the thing you already get. Okay, just draw the other three type of curve only. And what conclusion you can draw, right? Okay, now I want to tell you the conclusion you can draw. For this one, you can say, okay, I will give you the name of this curve also. Okay, it is not in the syllabus. But however, you can search it in Wikipedia. You can see this type of curve is called logarithmic spiral. Logarithmic spiral. Meaning that it grows in a logarithmic pattern. And spiral meaning that, do you know what is spiral? Something like this. Okay, it can be good. This particular example. Okay, and this is the name of it. Okay, and second thing conclusion you can say is the what can you say? The distance between the origin become bigger. Okay, you can say like this. Or you say the modulus become bigger. Distance between origin getting bigger lah, or increasing in mathematical word. Increasing lah better. Okay, increasing. Okay, last one. What is the direction? Still remember, direction we have anti-clockwise or clockwise. So this one is like this, anti-clockwise, ACW, I write, you write the full name, anti-clockwise, okay? So you can discuss these three things also. All of them are called a logarithmic spiral. Just two things you need to identify only, whether the distance increasing or decreasing, and the other one, direction, anti-clockwise or clockwise. I think that is enough for you already, okay? That much of thing only. Okay, now we will try the okay. For this one, okay, I will tell you. You can try to do it also, meaning that you set your A equal to what, and you let's say if I want to discuss A equal to 0, B greater than 1, I can set A equal to 0, B equal to 1. I substitute inside the formula, and then you generate your table, and then you plot by your own, or if you lazy, don't be lazy lah, use your calculator to check your answer whether correct or not. Okay, for all these one I and IV, all these you may check by your own. Okay, any question you all may PM me, but because this is coursework, I cannot fully help you. If not, that is not become coursework already. Okay, coursework meaning that center learning, you learn by yourself also lah. Okay, the conclusion you can make by yourself. Try to see what is the thing. Okay. You try to see by own. Okay. Now we discuss the last part. This one, correct? This one, task 4. Okay, this one actually is the Mori theorem for the root 1. Okay, the Mori theorem for the root 1. So given z power n equal to 1, okay, you want to find all the equation of the root. Okay, I will do it very simple, faster way already because the time is already there. Okay, I later got to go somewhere. Okay, let's say for n equal to 3, meaning that you want to solve This one is a bit blur, okay, but I think you already got the question. Okay, z power 3 equal to 1, right? If you want to solve this equation, what is the root? Try to verify by yourself using De Morey theorem. The root should be 1 negative 1 over 2 plus square root 2 over 2 I, right? And then the third one is the complex conjugate of it, like this. Okay, for the third case. Okay, use your De Morey theorem. Okay, if you don't know, you may watch back the thing. Okay, or new student, if you don't know, okay, you can ask me. Okay, for the root of 4, okay, z power 4 equal to 1. Okay, the root are 1 I, negative 1, and negative I. These are the 4 root. And the 5, 6, 7, you verify by yourself. What is the value? Okay. Let us discuss the sum of the root. What does it mean by sum of the root? Okay, meaning that I want to plus all the z0, z1, z2, z. Okay, let's say for this one, I plus them together. Okay, use your calculator to plus. Very easy. You can show that 1 minus 1 over 2, and then you minus another 1 over 2, right? Here you go, 2, 1 over 2. And then plus square root 2 over 2i minus square root 2 over 2i. Okay, this one you can cancel. So this one also end up in 0. So equal to 0. Sum of the root for the case of 3 roots equal to 0. Okay, 0. Similarly, for the case of 4, 1 plus I minus 1 minus I. Cancel, 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 cancel. All become 0 again. And you should be able to verify that all the case of 5, 6, 7 also same, but you need to do by yourself. Okay, this is your coursework. Okay, now what conclusion can you make? It seems like whatever n integer we have, also we can get the sum of root equal to 0. Okay, so the conclusion is the sum of root always equal to 0. Always equal to 0. Okay, for all to 0. For any n. Okay, for any n. For any n integer. Okay, you can use this notation, or you can say for any integer n. Both are okay. Okay, this is our conclusion only. It's not a proof. You guess only, but yes, it is true. Okay. Now, part B. Find the roots of the equation z n minus 1 equal to 0, where n greater than 2. Okay, represent this on the Argand diagram. Actually, I already discussed this. Okay, and z power n minus 1 equals 0, you can change it in this form, right? And then finally, it is just the same as what you have this just now. So meaning that you want to plot all the value on an Argand diagram. And I have shown you last time, I just plot two for you. You try to plot all of it. Okay. Here is 1, and here is negative 1 over 2, positive square root 2 over 2, minus square root 2 over 2. Here you have another 1 root. Wait, here you have 1 root. Here you have 1 root, and here you have 1 root. Okay, and finally, you will see that it is in a circle, right? Okay, this is not that good, the circle, but it finally is in a circle. Okay, wait, like this, a circle. Okay, a unit circle, still a unit circle, this one. Okay, same thing for the case of 4 and 5, 6, or 7, or same. Okay, try to plot it. Okay, and last time I mentioned another conclusion, remember? All of them can form a regular polygon, actually are the side of the regular polygon. But if you use another word, you say all of them lies on the unit circle, also can. So this is another type of interpretation you can make. Okay, here. Okay, the conclusion you can make is all the roots lies on a unit circle. Okay, on the unit circle. This is your conclusion. Can? Okay. I want to discuss it very fast. Okay, now suppose W, actually this is W, yeah, W equal to this thing is the root with the smallest positive argument, express this other root in terms of W. Okay, now like this, actually what they want is, maybe you can imagine a general one like this. Okay, power n, but this n is not specific, just simply give you one n only. Okay, now you want to solve it using De Morey theorem. Okay, so normally you will do like this, right? Make it 1, and then by using polar form of 1, it is cos 0 plus I sine 0. Here is Zn. So you want to find the n root. You take both sides 1 over n power. Okay, so your Z is Zn 1 over n, meaning that here 1 over n. Yeah, so revision 1 over n. But this is general. Your exam will be specific. Fourth root, big root. Okay, now still remember using the De Morey theorem, what you can have here will become cos 0 plus 2k pi over multiply by 1 over n, correct? Right, multiply by 1 over n or divide by n. Okay, and then I think better I put divide by n. Save some space. 2k pi divide by n plus I sine 0 plus 2k pi divide by n. Also, okay, and then you say your k is from 0, 1, 2, dot, 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 n minus 1. Okay? Okay. And then maybe you can change your form also, remember, but I think this one no need to change because difficult to change. Okay, you still have n, some variable. Okay, now just give one by one. What is your Z0? Z0 or Z0 lah. Z0 is your first root. First root meaning that you will substitute k equal to 0 inside here. Okay, and then you will give you cos 0 plus I. Okay, I will give you the longer one. 0 plus 2 0 pi over n plus I sine 0 plus 2 0 pi over n. You want to give the cis notation also can, but here I didn't use cos 0 plus I sine 0, which is equal to 1. So this is your first root. Okay, no matter what n is, you still have 1 as your one of your root. Okay, Z1. Okay, Z1, what is the value? 0 plus, you substitute n k equal to 1. So 2 multiplied by 1 pi over n I sine 0 plus 2 1 pi over n. Okay. Okay. So this is 2 pi over n plus I sine 2 pi over n. Here also same thing lah. Okay. Now this one you just leave like this only because n is an unknown. Okay, n is an unknown. So just leave it like this. Okay. And then I think do one more lah. You should be able to show that cos this one. Okay, you write blah blah blah, and then finally it is 2 multiply 2 pi over n plus I sine 2 multiply 2 pi over n like this. Okay, the multiple of the value 2 times. Okay, and then dot dot dot. What is Z final one? Final one is Zn minus 1. Okay, wait, maybe you can change this value lah. Not 0, 1, 2, but you start from 1 also, okay. You can have both lah, okay. Meaning that you start from 1 until n, meaning that is the first root until your n root, you have n root, okay. Okay, this one, meaning that you will substitute the last value, n minus 1, inside your k. So with your cos 0 plus 2 multiplied by n minus 1, pi over n plus I, all the same thing. Okay, here, actually, this is one. Let me think. Okay, sorry. It's not 2 anymore. Yeah, it's still 2. But then here now is n minus 1, 2 pi n, right? Plus I sine n minus 1, 2 pi n. Like this. Okay. The question give us a simplified form for the W. What is the W? W is I2 pi over n. Sorry, here I have another E. E to the I2 pi over n. This value. Okay, let us consider this one. See whether we can simplify it or not. Okay. Okay, W equal to this one. Okay, let's see what is this. Using the Euler's formula. Okay, substitute theta as substitute theta as 2 pi over n in your equation 4. You know what I mentioned to lah. Okay, in equation 4. Okay, cos 2 pi over n plus I sine 2 pi over n, right? This one. So this is W. It's the smallest positive argument. So this is what they say lah. Wait, it's the root with the smallest positive argument, which is your Z2, correct? Your Z2 equal to W, right? W. Okay, it's the same lah. Z1, just 1 only. Okay, now look what is your Z3. Your Z3, can it represent in any other form? Yes. Okay, because Z3, okay, here I need some space. Later, please, you all write in another paper. This one just a draft only. Okay, it will be very messy one. Trust me. So 2 pi over n plus I sine 2 pi over n, like this, right? You can factor the 2 out. Why? By using, again, De Morey theorem, the power one. Okay, here is 2, here is 2, so you bring the 2 out. Okay, what is the inside part? Inside part is exactly your W, right? It's your W, It's your W. So this whole thing becomes W squared. Okay, and similarly, so similarly, let's say if I put the middle one, you should know that your Z4 is equal to W4. Z4 equal to W power 3. W power 3. This is your Z4. Okay. And so on until your Z power n. Look here, the coefficient here is n minus 1. So it is W to the power of n minus 1. Okay, W to the power of n minus 1. Equal to W power n minus 1. Like this, right? Can? Okay. Now, so we are already done because they asked us to express the other roots in terms of W, and we are done here. Okay, show that 1 plus W squared plus dot 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 using the sum of geometric series. Okay, what does it mean by using sum of geometric series? Plus W power 3 n minus 1 equal to 0. Okay, using GP formula, okay, geometric series formula. Okay, this is what we want to show lah. Not equal to 0, but we want to show. Okay, now GP not only useful for real number, for complex number also same, but this is some extra thing already lah. Your exam won't test you on this, but I will tell you now, you can still apply the formula. A1 minus Rn over 1 minus R. Remember why? Because I have n term. Here also we have n term, even though here is n power 1, but you have n term over here. So your A is 1. 1 minus your R. What is your R? R is your W, correct? W power n. Divide by 1 minus W. You want to show that this one equal to 0. How to show? Very easily. Okay, see. Okay, what is W power n? So 1 minus W power n minus 1 minus W over 1 minus W. Okay, what is W? W is, substitute back, I 2 pi over n. Okay, power n. Okay, power n. 1 minus E I 2 pi over n. This one don't have power lah, so minus this one only. Okay. Okay, continue. Cannot. Later you have time, some time to copy lah. Okay. Okay. The upper one, you using index rule, n and n can cut. Okay. So left with I multiply by 2 pi. 1 minus E. This one is just W only lah. Just W only. Okay. It's okay lah. 2 pi over n. Okay. Now, use the Euler's formula, substitute theta as this one, substitute theta as this one, express these two things back to the polar form. Cos 2 theta, 2 cos 2 pi plus I sine 2 pi. Okay, 1 minus, this one also same lah, cos 2 pi n plus I sine 2 pi n. Okay. So you give it all the value. These two very easy only, right? 2 pi meaning that turn one round back to here. So 1 minus in the bracket here is 1 plus I multiplied by 0. 1 minus this one, you no need to care what is it. Okay. Okay. You actually don't care this also never mind. Okay. I will say you don't care this also never mind. So just copy and paste only. Just want to show that the upper part is 0, then the whole thing is 0, right? Okay. Okay, now 1 minus 1 upper part already becomes 0, right? Correct? So 0 over this thing, and then the whole thing will still equal to 0. And then we already done. Show. Okay, we already shown. Okay, now still have the last two part. Okay, now. Okay, so what happened? Wait, using the expansion. Okay, wait, just now like this, right? Actually, you have one more word to write. Okay, you must write that the down part is not equal to 0. You must write down part not equal to 0. But this is something you write by yourself, okay? Then only is not 0 divided by 0. And it's valid. Okay, anyway, just a very minor thing only. Okay, the part 2, using the expansion. Okay. Minus 1. Go to this one. Right? Excuse me. Okay, now. Okay. W minus 1. Substitute Z as your W, correct? So this is something identity, you already know. Okay, like this, plus w power n minus 1 bracket equal to z w minus 1. Sorry. wn minus 1. Okay, now, okay. Okay, what happened is wn, w is a root. Am I right? Okay, you can write like this. This is mathematical presentation. You need to write something. As w is a root of z power n minus 1 equal to 0. Therefore, meaning that we will substitute w inside the z, wn minus 1 also equal to 0 lah. Okay, it must satisfy this equation. Okay, root mean you substitute inside equal. Okay, which means okay, let's say this one is equation how many I don't remember already. Let's say give 10 okay, I forgot already. Okay, therefore the right hand side of equation 10 becomes 0, right? So meaning that this one becomes 0 already lah. Now w minus 1 and this one equal to 0, right? Still remember quadratic equation? When you have a multiply b equal to 0, you must have a equal to 0 or b equal to 0, right? W minus 1 equal to 0 or this one equal to 0. Two possibility only. Okay. I know this one is a bit difficult, so I will give you the full solution. Okay. Now, it is something like this. Okay. I remember I told you I think it's not you, the semester 2 one. Okay. Tea or coffee? Okay. Tea or coffee? Imagine I tell you tea or coffee. Maybe okay, I tell you like this. After this afternoon, I drink tea or coffee, meaning that one of it is true, right? And if I tell you another statement, I did not drink tea, not tea, meaning that it must be coffee, correct? This is a logic argument, okay, in a much more mathematics way, okay? Tea or coffee, but not tea, therefore coffee. It is like what? You remember in your SPM, P or Q? I think better to use this. P or Q, but not P, therefore Q. This is a argument. I will tell you this is an argument. So I want to show that this is false. I want to show this is false, so that I can conclude this is true and we are done. Okay? Meaning that I want to show W minus 1 equal to 0 is false. Okay, now I start by this. Now, W equal to, what is W? Excuse me. W equal to EI 2 pi over n, right? Or you expand it, become cos 2 pi over n plus I sine 2 pi over n. Okay, now, like this. Okay. You want to show that it is not equal to 1. Okay. It can only be equal to 1 if this one equal to cos 0 plus I sine 0, right? Wait, let me think of what is the better way to write. Okay, like this. Because I have the way in my mind. For your standard, I think the better way to write maybe it's like this. Say false. Okay, to prove it's false. Okay, now, okay, we assume it is true, then we make a contradiction. Okay, I will say like this, but this is the true way proof. Okay, Yeah, this one I give it in another page. Okay, today is so much thing, because this is a coursework, so it's okay lah, we do some extra thing. Okay, assume this is true. We want to make some contradiction. If we can make contradiction, meaning that this is false. Okay, this is the mathematical logic. Okay, assume this is true. So W equal to 1, which means cos 2 pi n plus I sine 2 pi n equal to 1. 1 is what? 1 is cos 0 plus I sine 0. Okay? If you compare here, and if you compare here, you will make a conclusion 2 pi n equal to 0. Okay, 2 pi n equal to 0. But n is greater than 2. And 2 pi also greater than 2. 2 pi also greater than 0, I would say. Okay. So meaning that when they divide, a positive number divided by a positive number will still be a positive number. However, our statement here is equal to 0, which contradiction? Which is a contradiction. Therefore, W minus 1 is not equal to 0. Okay, meaning that we already proved that, or in other words, W minus 1 equal to 0 is false. So we can make our conclusion, this is true. Okay, therefore, 1 plus W square plus W power 3 plus plus W power n minus 1 equal to 0 is true. Is true. And we have done the proof. This is the best way that I can give you lah. If you want to really the best way lah. Okay, but you just say you give some reference because your coursework you need to give some reference one, so you may find some reference supporting this. Okay, but you don't say it's me lah, because I can't be a legit references. Okay, now the last part C. For any two complex numbers Z and W, use the properties of complex conjugate to establish the relationship. Okay, wait, very fast only. Last part. Okay. See, Z plus W, I want to show this square plus this square equal to that, right? Okay, never mind. Now I will show you what theorem you will use. The theorem you will use is complex number Z square equal to Z multiply Z conjugate. Okay? Z star meaning Z conjugate. Remember, Z star meaning Z conjugate. Okay, I will only use this and I will prove it true. These are Z modulus square plus W modulus square. In fact, this is not easy, but you can try out on your own first. Okay, you can try out on your own first. If you cannot, then you look at my one also. Okay. How many of you? 4 of you only, right? Okay, I do it very fast. Okay, now first one, right hand side equal to Z plus W bracket Z plus W star, meaning that the conjugate of Z plus W. Why? This is still a complex number, meaning that we substitute. It kind of like substitute in, this is what equation, let's say equation 11. Okay, you substitute Z plus W in equation 11. Z equal to Z plus W. Okay. Maybe here I don't want to put Z, I put A. Better. Okay. Substitute A equal to Z plus W in equation 11 and A equal to Z minus W in equation 11 also. Okay. So we can give this plus Z minus W multiplied by Z minus W bracket star, the conjugate of it. Just me. Okay, now. Okay, now actually you will use the second theorem lah. I will say so we use the second theorem. Second theorem is what second theorem. Ah wait Second theorem is this: A plus B conjugate is equal to A conjugate plus B conjugate. If you are interested, you can try to prove it. But this is what the theorem you will use. You'll be using. Okay, so now you're using theorem using equation 12. Okay, so this one becomes Z conjugate plus W conjugate plus Z minus W, and this is Z conjugate minus W conjugate bracket. And then you do the multiplication of complex number. Z conjugate plus ZW conjugate. Yeah, you should know how to do this. So you when you fast forward. This one plus W Z conjugate plus WW conjugate. Next, Z conjugate minus ZW conjugate. And then last one, minus WZ conjugate and plus WW conjugate. Okay, can? Finally, you will see that this one and this one can cut, and this one and this one can cut. And you combine these two, so you have 2Z conjugate, and then you have 2W conjugate. Again, apply equation 10, A square conjugate, any complex number multiplied by its conjugate is equal to the modulus of Z. So using it again, just substitute only sub A equal to Z and A equal to W into 11. So this is Z square and W modulus square. 2 of this plus 2 of this, and we have done the proof. Okay, almost 11 p.m. already. Okay, I'm very tired. Okay, now last. Can later I will give you this one. Okay, don't worry. Okay, last. Sketch the x and y as a vector in Argand diagram. Is Z and W are from a parallelogram. Form a parallelogram. Wait, this one very blur. Wait, let me look at the question. One more time. Here. Okay, if Z and W form a parallelogram, find the length of the diagonals. Length of the diagonals of the parallelogram in terms of Z and W. Give a geometric interpretation of this. Yeah. Okay. Now Z and W in Argand diagram. We're gonna give me something. Okay, continue. Okay, we sketch a parallelogram. So let's say, just simply draw two only. Simply draw two only. So this is Z and this is W. Let's say let's say in Argand diagram, imaginary, real part. Okay. If they can form an parallelogram, so meaning that what does it mean by parallelogram? Like this, okay. I'm not sure whether you can see or not, but I think better I do like this. W, and Z. This is what it means by a parallelogram. Here angle same, here angle same. In vector, later chapter 6, you will see what is parallelogram. Okay, what is the length of the diagonal? Okay, in terms of Z and W. Okay, so the length is Sorry, this one. Okay, you have here and here, right? You have here and here. You have two diagonal. Okay, you have two diagonal. Okay, look at here. We take any one of it lah. Okay, let's say we see this one first. Okay, this is the length of the diagonal, correct? Diagonal meaning that is from one corner to the opposite corner, or from the one to here also same. Okay. Okay, now give me some time. Okay, we look at the first one. If first one, if in terms of vector, so that's why actually you need also some of the vector thing. Here is Z plus W, vector addition. So here actually is another vector called Z plus W. Okay, this one is called Z plus W. Yeah, correct. Wait, Z plus W. Let me see. Correct lah. Z plus W. Okay. Okay, you have two diagonal. Please mention you have two diagonal. Okay. So one of the diagonal is called Z plus W. So if you want the length of this diagonal, meaning that you want the modulus of Z plus W, this is the length of the diagonal of the parallelogram. Okay. So what is this value equal to? So this value equal to what? Okay, by using the formula that you have been proven just now. Just now was this one square plus this square equal to 2z modulus square 2w modulus square. Okay, so this is what you want, correct? So you express this in terms of the other line, z plus w square equal to, so you pindah the other one to the other side, become like this already, minus z minus w square. Okay, like this. And then you want the square root, correct? Because you want what is z plus w. This one, okay? Okay. Have a moment. Definitely, it is a positive value. So when you take the square root, we will just take the positive square root only of this. Minus z minus w square. Okay, take the positive square root. And we are done. Then this is the length of the diagonal. You must mention one diagonal, length of the diagonal of z plus w. Okay. You still have the other one, the other one more. Okay, the other one more is this. Okay, here is another one. Here is another diagonal. You have two diagonal. Okay, this diagonal, what is the vector? So from here, you want to go to here. Look at the the vector. Here is w, and then here is it z. It is not z, but it is negative of z, right? From here go to here, it is negative z. I will tell you. Here go to here, negative z. May I use a different color? Here go to here, negative z. Okay, so meaning that the blue color line is your w minus z. Okay, w minus z, or z minus, okay, w minus z, I will say. Okay, w minus z. Okay, I will do like this. So the other diagonal is called w minus the modulus of this. Okay, but it is actually the same as z minus w modulus. Why is it so? Because you can take out a negative, so it becomes z minus w, correct? Okay, I already changed the sign. Okay, And you know a modulus of any negative value is equal to the positive value. So you turn the sign also become the same lah, to the modulus. Okay. Now if we are interested of this, similarly using the same equation just now, let's say this is equation 12 lah. So we were using equation 12, prove by yourself. So this one equal to what? Square root 2z square 2w square minus z plus w square. Okay. Can I think geometric interpretation of this relationship. Yeah, geometric interpretation of this relationship. Okay, geometric interpretation. And actually I didn't see this instruction. So now let me see this. Give a geometric interpretation of this relationship. So what can I see from here? Okay. Geometric interpretation. Wait. Okay. What is the relationship between these two formula? I mean between these two diagonal length. Okay. These two diagonal length. Wait. Hold on. Okay, if me, I will just write like this. That's it. A very simple one. The square of the square. Let me construct my sentence. The sum of the squares of the diagonal length equal to the sum of the 2 times of the square of the sides, very so many of the parallelogram. But this is not very intuitive. Actually, I just write whatever I can see from the formula 12 only. The sum of the square, meaning that this is the sum, we plus the square of the sum. What is the sum? Z plus W and Z minus W is the corresponding diagonal. Diagonal. Okay, is equal to the sum of 2 times. 1, 2 times. Here got 2, 2, right? 2 times of the square of the sides. Why sides? Because Z and W are the corresponding sides of the parallelogram. This is what I can think of the geometric interpretation of the relationship. If I happen to see any other thing in further, I will let you know. Okay, so that is all for the solution for your this one. Okay. Okay. I think I will stop recording here. Finally, for today we already do 3 hours. Okay, I think I will stop right now.